Kirchhoff's laws and combinations of resistors. Resistors in series. Resistors in parallel. The potential divider. Copyright John Parkinson, The Algebraic Sum of the Currents. Kirchhoff's first law. I equals 0. The algebraic sum of the currents at a junction is 0. I3, I4, I1, I2, I5. I1 plus I2 equals I3 plus I4 plus I5. Copyright John Parkinson. Putting IT simply equals current out. Current in equals current out 0.5 A. Example A 0.3 A 0.5 A 0.3 A equals 0.2 A. Copyright John Parkinson. Kirchhoff's second law. Around a closed circuit loop, the algebraic sum of the EMFs is equal to the algebraic sum of the PDS. R1, R2, R3, R4, IR1, IR2, I4R3, I4, I4, then equals IR1 plus IR2 plus I4, R3. For R3 and R4 loop, 0 equals I4 R4, I4, with no EMFs in this loop. Copyright John Parkinson. Example. A battery charger has an EMF of 14V, and an internal resistance of 1.6. It is used to charge a 12V battery, which itself has an internal resistance of 0.3, through a 1 resistor. Find the charging current. Charger equals 14 volts to 12 volts equals 2 volts. 0.1. 1.6. Sum of PTS equals IR. 90.3 plus 90.1 plus 91.6 equals 92. 12I. 14V. So 2 volts equals 92. 0.3. Charger I equals 1A. I. Copyright John Parkinson. By Kirchhoff's second law. Resistors in series. E.M.F. equals R1, R2, R3, I equals IR1 plus IR2 plus IR3 equals IR1 plus R2 plus R3. By Kirchhoff's second law. If we apply Ohm's law to the whole circuit, we have equals IR, if R is the total resistance. So IR equals IR1 plus R2 plus R3. R equals R1 plus R2 plus R3. Dividing each side by I. Copyright John Parkinson. By Kirchhoff's first law. Resistors in parallel. EMF equals. By Kirchhoff's first law. I equals I1 plus I2 plus I3. I1. R1. We now apply Ohm's law to each component and to the whole circuit, letting R equals the total resistance. I2. R2. I3. R3. Dividing each side by V. Copyright John Parkinson. Example. Find the current in each resistor. Source equals 20 volts. What is the combined resistance of B and C? Source equals 20 volts. IB. B equals 12. So the total resistance in the circuit, including A, is 4 plus 6 equals 10. A equals 6. 8 volts. C equals 6. What is the current taken from the battery and the current in A? IC. 20 volts 10 equals 2A. The PD across B and C is given by V equals IR equals 2A x 4 equals 8 volts. Hence find IB and IC. IB equals VR equals A12 equals 2/3 amps. IC equals VR equals 86 equals 4/3 amps. Copyright John Parkinson. In the same ratio, A the resistors. The potential divider. A. If no current is drawn through the output, then, by Ohm's law, I R1, then B R2 Vout, and Vout equals 9 or 2 C. So, the voltage is divided in the same ratio A the resistors. Copyright John Parkinson. Example 150 volts of Vout B, so Rab equals 5 ohms, Vout equals 75 VY. I, find Vout. K. A. 10. K. Vout. 2. Find Vout, if another 10K resistor is connected across AB. B. So Rab equals 5 ohms. Vout equals 75 V. Y. Copyright John Parkinson.